one way we can get things done is we can look at a number, we can look at all the factors that can be broken down, prime numbers to make the coefficient, break down the variables all the way. That's one thing we can do. Sometimes we just have to be listing all of these different factors. So that's all the different numbers that you can break something up into. Every single possible combination of the factors. And it has value, it has worth, but as you get better with this, you'll do more and more of it in your head. So, like the first, let's just look at number one. Have you done number one? Well,
I started with
messing around. This is 21x cubed, right? So if you listed all the factors, that would be like all of the pairs of numbers. You can think of it that way, that multiply out to make 21 times x cubed. This becomes pretty exhaustive. I mean, some of these here will do more than fill the line. They'll be just a wreck. So what I would suggest you do with this is start by doing the prime factorization of the coefficient. So what is 21 equal to?
7 times 2.
7 times 3. So if I write 3 times 7, I've got the 21 taken care of. And now x cubed is x times x times x, isn't it? So this is everything factored all the way down as far as you can get it. And if you take combinations of anything here, they would all be factors. So if we're going to list them all, so the list of factors, I mean, you can use 21, right? You can use 3, and you can use 7. And actually, hold on. I want to organize this a little bit differently. How about if we do it this way? We can use 3, we can use 7, and we can use 21. Now, all of the different ways of listing this could be x, x squared, and x cubed. If I took one of them, two of them, or three of them. So now you can put any of these coefficients in front of any of these. So it's sort of like this. These are all factors, these are all factors. So is 3x, 7x, 21x, 3x squared, 3x cubed. That's everything, if you organize it that way. It's kind of a holy wreck, isn't it? It's a big mess. What if you did 6yz? Write it out as just the prime numbers and the individual variables. See, the purpose behind problems like this is just to get you thinking about what multiplies together to make 6yz or 21x cubed. So what are the primes? How would you write this as just prime numbers?
6, 3, 2.
What is 6 equal to? What two prime numbers? What did you say? 3 times 2? Can I write 2 times 3 that way? Write them in the... And then you have times y times z. So if you do 2 and 3 and y and z, you can have 2 times y, 3 times y, 2 times z, 3 times z. And if you did y times z, you could have 2yz and 3yz. And then if you had 6, you could have 6y, 6z, or 6yz. So that's a list of everything. That's every single factor. We don't need to know them all, but there they are. What matters more are things like questions 3, 4, 5, and 6. Here you want to find the greatest common factor, and that's what we were doing before. you want to find the biggest common factor between two numbers. So here we have 3m squared and 24m squared n. So it's kind of a two-step strategy, or maybe 3 steps, or 4 steps, however you want to look at it. But it's a step-by-step strategy. It's not a in your head one time and you're done. If we start by looking at the coefficients, that's what I would do first, because they're written first. Work from left to right. What's the greatest common factor between 3 and 24? 3. 3 goes into 3 once. It goes into 24 how many times? 8 times. Good. Then you look to the first variable, m squared, m squared. What's the greatest factor common to this? M squared. Because it goes in here 1 time, and it goes in here 1 time. So now, is there an n here? There's an n there.
Yeah.
Oh, which one's m cubed? This is?
3 and
Oh, I'm sorry. Okay, hold on. So let's check. Is this still the greatest common factor? You can put m squared into here 1 time. How many times does it fit into here? So in other words, m squared times what number equals m to the 3rd? Times m. So it goes in m times. Here, it goes in 1 time. So yes, that's the greatest common factor. Now you look for n's, but there's not an n here. So could I say that n is a common factor? No, it's only a factor of that. So there you are, 3m squared. That's it. Done. Now, I want to carry this problem a little further. What if we said that we were going to add these two together? And we said that we were going to take the greatest common factor times a binomial. What would have to go here to make it equal to this? Just m. What would have to go as the second term to equal this? Three times 8, and then n. So there, we just factored that as though it was a binomial. So what this lesson master is leading you into is, first of all, finding the greatest common factor, but then factor the whole thing out. So this is equal to this. Do the next one. Do number 4. Find the greatest common factor. Good. You see a fast way through all of these? Yeah.
Is that right?
Yeah.
Okay. I was just checking. I wasn't sure about them going into that, but
Could you explain that to somebody?
no, I could not.
Fiona?
If they understood what I was saying.
What's the third one, number 5?
15 S to the third, T to the fifth.
To the 4th? Can you? Can you tell them?
Well, I don't think I got that one right. I just said 3 because none of the factors relate to all 3 of them.
Okay,
That's the second.
So Marvis, Fiona's talking, and when she talks, I'm gonna hear it, and then I'm gonna say it louder, unless you say it real loud. So you said something about 3.
Yeah,
Why 3?
because it goes into all of them. It's the biggest one.
Goes into all of them. And it's the biggest one. Okay, then what comes next?
Well, I think I got that one wrong. I didn't say anything for that because the S and the T don't go into all of them. Well, S doesn't go into all of them and T doesn't go into all of
Yeah,
them.
S doesn't go into all of them, does it?
So it'd be 3.
And T doesn't go into all of them, so
Just 3.
it's only 3, isn't it? Because there's 3 here. But if you were just looking at the first 2,
It'd be S2,
S to the what?
2 squared.
To the second power, why?
Because the second one doesn't have S3, so
Yeah,
it's
so there's not enough S's here. There's only 2 here, but there's 3 there. So 2 is in common in both. So what did this come out to? 4.
PR squared.
So if you look at the P's, this is the first, that's the second. You have to look at, Raven was telling me, the highest power. So that power is just 1. That power is 2. That's the highest that fits into both. And then you gotta do the R to the second. That's all you get for this one. There's a lot. This is a really, really long lesson, Master, and I don't want you to absolutely do all of them. But a lot of you got through 6, I saw. So let's for sure do 7. Writing this out for Jackson. Let's for sure do 7. Let's for sure do 8. Even 9. And 10. And 11. And 12. When we come back tomorrow, we're going to look at the back side of this. It's some of the same ideas, but a little bit more complicated. So, yeah, so basically work through the first 12. We've got, I think we have time left, don't we? Yeah, we're here till 10:30.